Friends, welcome to this channel. Today I am going to solve miscellaneous exercise on chapter number 1. First question of miscellaneous exercise on chapter number 1 is let function r tends to r be defined as fx is equals to 10x plus 7. Find the function g r tends to r such that gof is equals to fog is equals to I base r. Solution for this question. Miscellaneous miscellaneous exercise miscellaneous exercise solution 1. Let f x tends to I, where x is subset of R and y is subset of R. Consider 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 an arbitrary element y of capital Y. By definition y is equals to 10x plus 7 for some small x belongs to capital X. X is equals to y minus 7 upon 10. Let us define y tends to x by gy y minus 7 upon 10. Now g of x is equals to g, fx is equals to fx minus 7 upon 10 is equals to 10x plus 7 minus 7 upon 10 is equals to 10 is equals to x, and fog y is equals to f g y is equals to 10 gy plus 7 is equals to 10 y minus 7 upon 10 plus 7 is equals to y. Gof x is equals to IR and fog y is equals to IR. Therefore, f is invertible g y tends to x such that gy is equals to y minus 7 upon 10. Answer question number 1 is completed. And question number 2 says that let f w tends to w be defined as fn is equals to n minus 1 if n is odd and fn is equals to n plus 1 if n is even. Show that f is invertible. Find the inverse of f. Here w is the set of all the whole numbers. So solution for question number 2. Solution for question number 2. We are given we are given w tends to w defined as function n is equals to n minus 1, n is odd, n plus 1, n is even. Let function n1 is equals to function n2 if n1 is odd and n2 is even. N2 is even, then n1 minus 1 is equals to n2 plus 1, that is n1 minus n2 is equals to 2, which is not possible, which is not possible, which is not possible as n1 is odd, n1 is odd, n1 is odd, n1 is odd, and n2 is even, n2 is even. When n1 and n2 both are odd, then f function n1 is equals to function n2 is equals to n1 minus 1 is equals to n2 minus 1. Therefore, n1 is equals to n2 when n1 and n2 both are even. Function n1 is equals to function n2 is equals to n1 plus 1 is equals to n2 plus 1. Therefore, n1 is equals to n2. This shows f is 1 1, any odd number 2r plus 1 in codomain codomain is the image 2r and any even number 2r in the codomain is the image of 2r and any even number 2r in the codomain w in the image 2r plus 1. Therefore, f is 1 1, and on 2. Therefore, f is invertible. Further, when n is odd, y is equals to n minus 1, n is equals to y plus 1. Y is even when n is even. N is even. Y is equals to n plus 1. N is equals to y minus 1. Y is odd. Y is odd. Hence f inverse y gy is defined as w tends to w such that g function y minus 1 if y is odd, y plus 1 if y is even. The inverse of f the inverse of f is f itself. Hence our question number 2 is completed. Now I am going to move on question number 3. Question number 3 says that if function r tends to r is defined by fx is equals to x square minus 3x plus 2, find f bracket f round bracket x. Solution for question number 3. Solution for question number 3 is fx. Solution of question number 3. Fx is equals to x square minus 3x plus 2. Fx is equals to fx का whole square minus 3 fx plus 2 x square minus 3x plus 2 का whole square minus 3x square minus 3x plus 2 plus 2 x की power 4 plus 9x square plus 4 minus 6x cube minus 12x plus 4x square minus 3x square plus 9x minus 6 plus 2 x की power 4 minus 6x cube plus 10x square minus 3x. Which is our required answer? Let's move on question number 4. Question number 4 says that show that the function f r tends to x belongs to r minus 1 is less than x is less than 1 defined by a function x is equals to x upon 1 plus mod x belongs to r is 1 1 and onto function. So solution for question number 4 is solution solution for question number 4. Let x is greater than or equal to 1, function x is equals to x upon 1 plus x, fx1 is equals to fx2, x1 plus 1 upon x1, x2 1 plus x2, or x1 1 plus x2 is equals to x2 1 plus x1, or x1 plus x1 x2 is equals to x2 plus x2 x1. Therefore x1 is equals to x2 when x is less than 0. Then fx is equals to 1 minus x 1 minus x, function x1 is equals to fx2, x1 1 minus x1, x2 1 minus x2, or x1 1 minus x2, x2 1 minus x1, or x1 minus x1, x2, x2 minus x2, x1, x1 is equals to x2. F is 1 1. Therefore F is 1 1. Now second one, as minus 1 is less than x less than 1, and fx is equals to x 1 plus mod x lies between minus 1 upon 2 and 1 upon 2 when x is greater than equals to 0. Let y is equals to 1 plus x. Therefore 1 plus x, y is equals to x, xy minus x is equals to y. Therefore xy minus 1 is equals to y. Therefore x is equals to y upon y minus 1. When x is less than 0, fx is equals to x upon 1 minus x. Therefore x is equals to y minus xy, y minus xy, x 1 plus y is equals to y. Therefore x is equals to y. In both cases, each value of y codomain of f has a unique value in its domain. Hence f is onto. Thus f is 1 1 and onto. Hence we have completed our question number 4. Now I am going to move on. I am going to solve question number 5. Question number 5 says that show that the function f r tends to r given by fx is equals to x cube is इंजेक्टिव. ये लास्ट क्वेश्चन होगा. बचे हुए क्वेश्चन हम लोग 6 to 19 अगले 2-3 वीडियोस में बनाएंगे. अभी हम क्वेश्चन नंबर 5 को सॉल्व करने जा रहे हैं. अगर आप चैनल को सब्सक्राइब नहीं किए, चैनल को सब्सक्राइब कर लें. प्लीज़ डू लाइक द चैनल. Please do like these videos. Now question number 5. Solution of question number 5. Question number 5. Fx function x is equals to x cube. Function x1 is equals to fx2 is equals to x1 cube is equals to x2 cube. X1 is equals to x2. Therefore f is 1 1. That is f is injective. Hence we have completed our question number 5. अभी तक आपने चैनल को सब्सक्राइब नहीं किया तो चैनल को सब्सक्राइब कर लें. प्लीज़ डू लाइक एंड शेयर विद योर फ्रेंड्स. क्वेश्चन नंबर 6 से हम लोग 19 क्वेश्चन तक अगले कुछ वीडियोस में हम लोग 2-3-4 वीडियोस में बारी से 5-10 मिनट 15 मिनट 20 मिनट की वीडियोस बनाकर उसको करेंगे. तब तक के लिए धन्यवाद. डेट्स ऑल from my side. Thank you everyone.